Okay, in order to prove that f and g are inverses, we have to prove that f of g of x will return a value of x, and that g of f at x will return a value of x. Now, in the first video on 5a, I went into a little bit more description of why this is occurring. I'm going to shortcut that and not give you the full spiel on it again. What I'm going to do is demonstrate that if I put in function g into function f, that I will return a value of x, which means f will undo whatever g does. So we got to put into function f the value of function g, which is 1/2 times the square root of x. This is going into function f. I want to verify that it's going to be equal to x once we simplify. Well, this has to go into function f, and function f says you have to take 4 times your input, which is 1/2 times the square root of x, and then square it, because it says whatever your input value is, square the thing. So we're squaring here. Now I'm going to show and demonstrate that that's going to equal just an x. If I can do that, then their inverses at least have a shot. Next thing I want to do is I want to apply my order of operations, which means I have to square first. Now to square means I have 4. There's a couple ways to think of this. It's a 1/2 times the square root of x times another 1/2 times the square root of x. You could do that, or you could apply your monomial rules for exponents, which means if you have a power raised to a power, then you have to take 1/2 and square it. So 1/2 times 1/2 is 1/4. When you square a square root, that'll give you the inverse, so that'll just give you an x. So the square root of x squared is just x. Can I verify that that's going to give me only a value of x? And then I've got a fourth of x times 4, so 4 times a fourth. If we just multiply these together, it's not a distributive rule because it's not addition. I just multiply 4 times a fourth is 1x, which equals x. So this one, this prong, or this side, verifies that they're inverses, so f will undo g. On the other side, we want to put f into g and prove that they will undo each other and get back a return value of x. So no matter what we put in to f, g will take that output and return the same input that we started with as x. So f is going to go in to function g. So I'm going to replace f at x with what f at x is. It's 4x squared. I want to prove that I will get an x in the return. Now that means 4x squared is going into function g, and g says you take 1/2 times the square root of your input, and your input is your 4x squared. I want to verify that that will give me an x. So now we're going to take the square root of 4x squared, so it's 1/2. You can think of this as the square root of 4 times the square root of x squared, if that helps you. Remember, you can always take the square root of a product and write it as the product of the square roots. That helps some people see the relationships here. So it's going to be 1/2 times the square root of 4 is 2, and the square root of x squared is x. Does that give me a return value of just x? And 1/2 of 2 is 1, so 1 times x is x, which is exactly what we wanted to find. So we found out that both g and f are inverses of each other, so therefore f and g are inverses. And I've showed you through a pretty step-by-step procedure of what's going on. It's not just I get a basic idea and then I write down x equals x. You need to prove to me and verify to me how you're getting these solutions, and if you don't, you're going to get deduct points based on the merits of your showing and proofing.